Myself K. Vijay Kumar. I am from Mechanical. Today I am explaining about Circulant NO-matrices. Introduction to Circulant NO-matrices. Circulant NO-matrices are as a specific type of square matrix with a special structure. They are characterized by having constant values along each diagonal with the values repeating in a cyclic manner. Circulant NO-matrices are of particular interest in various fields including signal processing and linear algebra. And definition and properties. A circular matrix is a square matrix where each row is a cyclic shift of the previous row. The cyclic shift is performed by moving each entry one step to the right and wrapping the last entry to the first position. Circular no matrices are always symmetric with equal values along each diagonal. Circular is a special case of top list matrix. Each row column is generated by a circular shift module of the previous row column. Construction of circular no matrices. Circular no matrices can be easily constructed using a vector or a row as a starting point. The first of matrix determines the entire matrix as such subsequent row is a cyclic shift of the previous row. The values in the first row can be chosen appropriately as long as they follow the cyclic shift pattern. Block circular matrix can be equal to F is equal to F power T1 is equal to F power Tn is equal to whole power T. Cf is equal to F1 F2 dot Fn minus 1 Fn F2 F3 so on Fn minus Fn comma F1 so on comma Fn minus 1 Fn so on comma Fn minus 3 Fn comma F1 so on Fn minus 2 Fn minus 1. Equivalent definition is block circuitant is equal to where n is equal to 0 comma in minus 1 by in minus 1 comma 1 comma 0. Properties of circular no matrices. Circular no matrices are always diagonalizable, meaning they are expressed as a product diagonal and similarity matrices. The eigenvalues of a circular matrix can be easily determined from the first row of the matrix. The eigenvalues of the discrete Fourier transform of the first row. Applications in signal processing. Circular no matrices are widely used in signal processing for filtering and convolution operations. They enable efficient implementation of linear time invariant systems. The fast Fourier transforms of FFT logarithm exploits the properties of circular no matrices for efficient computation. Signal processing applications. Signal processing is equal to application of algorithms to modify signals in a way to make them more useful. Goals: efficient and reliable transmission, storage, and inflow of information extraction and enhancement. Examples: speech and audio processing, multimedia processing, underwater aquatic, biological signal analysis. This is called application and signal processing. Applications in signal processing. Next, applications in linear algebra. Circular numbers of applications in solving linear systems of equations. They can be used to solve systems with periodic boundary conditions. Circular numbers also play a role in solving partial differential equations. Matrix equation. A linear system can be written as a matrix equation X equal to B. Here the coefficient matrix, variable matrix, constant matrix. 5x minus 4y is equal to 8. 1x plus 2y is equal to 6. These are both two equations. This is called applications in linear algebra. Computational complexity. The computational complexity of matrix vector multiplication with a circular no matrices is on n log n, where n is the matrix is completely significantly lower compared to general matrix multiplication algorithms. The efficient computation of circular no matrix operations contributes to their wide applicability. Multiplying matrices A1, A2, A3, A4, A5, A6, A7, A8, A9, and B1, B2, B3, B4, B5, B6, B7, B8, B9 is equal to C1, C2, C3, C4, C5, C6, C7, C8, C9. And the colored one are A1, A2, A3, and in second row B1, B4, B7, and C in 0, C1. These are the computational complexity. Example Example, circular no matrix construction. Let's consider an example of constructing a circular no matrix. Starting with first row 1, 2, 3, 4, we generate the subsequent row by syllogistically shifting the previous row. The resulting circular no matrices is 1, 2, 3, 4, 4, 1, 2, 3, 3, 4, 1, 2, 2, 3, 4, 1. Next, Toplitz and circular matrix. A Toplitz matrix T is a matrix then a constant elements along the main diagonal and the side diagonals. Matrix C is called circular if each row of its row is a circular shift of the previous row or columns. Now note that C is also Toplitz and Cm comma n is equal to Cm comma n modulo n. And this is the example of circular no matrix construction. And the next example is application signal processing. In signal processing, circular no matrices can be used for filtering operations. Let's consider an input signal 1, 2, 3, 4 and a circular no matrices 1, 2, 3, 4 as the filter. The output signal after convolution can be calculated efficiently using the FFT algorithm. Signal processing applications. Signal processing involves applications of algorithm modify signals in a way to make them more useful. Goals: efficient and reliable transmission, storage, and display of information. Goals: efficient and reliable transmission, storage, and display of information. Information extraction and enhancement. Example: speech and audio processing. This is called the speech and audio processing. And multimedia processing, image and video. There is a multimedia processing and the image and video also. Underwater acoustic, biological signal analysis. There is an option of biological analysis, signal analysis. Last and the conclusion. Circular no matrices are special type square matrices with the constant values along. They have signal applications in signal linear algebra and solving differential equations. The computational efficiency of circular matrices operations make them a powerful many fields. Then x naught x n minus 1 x n minus 1 so on x1 x0 x n minus 1 so on x2 x1 and x3 and so on xn minus 1 xn minus 2 xn minus 3 so on x naught. And thank you.